All right, let's get right into it. We're going to talk about one of the most powerful and honestly kind of mysterious pieces of tech inside your computer, the graphics card. I mean, if you've ever just sat back and been blown away by the graphics in a video game, or if you've heard about what's driving things like crypto and AI, well, you're in the right place. Because it all comes down to this incredible piece of hardware we're about to break down.
So let me just ask you, how powerful do you really think your graphics card is? Like, what are we talking here? A million calculations a second? A billion? Let's try to put a number on it.
Get this, 36 trillion. That's the number of calculations a modern GPU can crank out every single second to create a world like the one in Cyberpunk 2077. It's a number so big, it's hard to even wrap your head around.
So, let's try to put that in perspective. Imagine every single person on our planet doing one long multiplication problem every second. To get to the same power as just one of these chips, you'd need the entire population of about 4,400 Earths, all of them, calculating at the exact same time. It's just wild.
It is an absolutely insane amount of computing power to have in something that just sits on your desk. So, the big question is, how on earth is that even possible? Well, the answer is in a totally different way of thinking about how to process information.
And to get that difference, we need to look at the two brains inside your computer, the CPU and the GPU. And you know, the best way I've heard it described is to think about a jumbo jet versus a giant cargo ship.
Okay, so your CPU, that's the jumbo jet. It is incredibly fast, it's super flexible, and it's designed to handle a few really complicated things at once, like running your operating system or your browser. It has a handful of very powerful cores. But the GPU, that's the cargo ship. It's not nearly as fast or as flexible, but it is built to do one thing on an absolutely massive scale: move a ton of cargo. It does this with thousands, and I mean thousands, of simpler cores that are just really, really good at one basic thing: arithmetic.
So let's zoom in on that cargo ship and see how it's actually built. And a great way to picture a GPU chip is like a giant, super organized city. A city populated entirely by simple little calculators.
And this city has a very clear structure. The whole chip itself, that's the city. That city is broken up into different districts, which are called graphics processing clusters, or GPCs. Then inside each district, you've got smaller neighborhoods called streaming multiprocessors, or SMs. And finally, inside every single one of those neighborhoods, you have the individual workers, thousands of them, the cores that do all the actual work.
Now, not all of these workers are doing the same job. You've basically got three types. The most common are the CUDA cores. Think of them as the grunts. They're just simple calculators doing basic math. Then you've got the tensor cores, which are specialists in the kind of matrix math that you need for AI. And finally, you have the big guys, the ray tracing cores, which are built for the really tough job of figuring out how light bounces around in a 3D scene.
Okay, so here's a really cool little industry secret. Making one of these chips with billions of tiny parts is extremely difficult, and little mistakes happen all the time. But instead of just throwing away a chip because of one tiny flaw, manufacturers do this clever thing called binning. They just test the chip, find the faulty little neighborhood or worker, switch it off permanently, and then sell that slightly less powerful chip as a different, cheaper model.
And this table shows you exactly how that works. Just look at this. The super high-end RTX 3090 Ti and the much more common RTX 3080, they are the exact same piece of silicon, the GA102 chip. The only difference is that the 3090 Ti is a perfect one, with every single worker active. The RTX 30 is one that came off the line with a few defects, so as you can see, they just deactivated 16 of those neighborhoods, the SMs, and sold it as a 3080. It's a super efficient system.
Okay, so we've got this huge city full of simple workers. But how does that turn into unbelievable speed? Well, the secret ingredient, the magic, is a concept called parallelism. It's all about getting every single worker to do their job at the exact same time.
And the core idea behind it is called SIMD. It stands for Single Instruction, Multiple Data. And it's a beautifully simple idea. You give one single command, and that one command is carried out by thousands of workers simultaneously, but each worker is doing it to their own little piece of data.
So let's make that real with this cowboy hat. A 3D model like this is just a collection of thousands of points in space, right? To make the hat move, you don't send 14,000 different instructions. No, you send just one command. Move this point.
And that single instruction goes out to 14,000 different cores. Each one calculates the new position for its own unique point, and they all do it at the exact same time. Boof! The whole hat moves in one go.
And that makes GPUs the perfect tool for solving what computer scientists call embarrassingly parallel problems. I love that name. It just means any job that's super easy to break up into thousands of little pieces that don't depend on each other at all. The calculation for one point on that hat doesn't care what any of the other points are doing.
And this principle? This is exactly why GPUs are suddenly so critical for everything, not just for gaming. Things like crypto mining and artificial intelligence, at their very core, they are all just embarrassingly parallel problems. Think about it. In games, you're applying the same math to millions of points all at once. For crypto, you're running the exact same guessing algorithm over and over with slightly different numbers, hoping one hits. For AI, you're doing trillions of simple matrix math problems to train a model. It's all the same trick. One instruction, mountains of data.
So, if you take one thing away from this, let it be this. A graphics card's incredible power isn't because it's smarter than a CPU. It has nothing to do with complex thought. It's pure brute force, accomplished by a massive, perfectly organized team of simple workers all doing the exact same tiny job perfectly in sync.
And that kind of leaves us with a final question, doesn't it? We've seen this architecture completely change gaming, and now it's doing the same for AI. So as these technologies keep getting bigger and more demanding, you have to wonder, what other huge, embarrassingly parallel problems are just sitting out there, waiting to be solved by this incredible power of synchronized simplicity?